Hello, this is Paul Gregg. I'm taking a different subject altogether from my normal engineering-related things, and I'm going to talk about a subject that I learned about in college, how to calculate compound interest, basically, and there's a lot of young people that seems to me need this. They get a lot of bad information from people who want to take their money. And I want to motivate young people to save, to invest, and to make better decisions and make some sacrifices that they can keep more of their money and have a little more stable life. I call it the mathematics of wealth, the time value of money, what wealthy people know. There's people who know how money works, how interest works, and they get on the side where they're being paid interest, and there are other people who pay interest. And it's my basic message is that it's better to have someone pay you interest than to pay them. And I know that sounds easy, but it might be easier than you think. And my goal here is to motivate young people. So my goals here, it's not just wealthy people or people that are born rich that can be smart with money. That's a fallacy. We all have some grudge against someone who inherits a lot of money, but you can't worry about that. You can do what you can, and you can understand money, understand the equations that govern money. And I believe with a knowledge of the time value of money, anybody can save and invest their way into financial stability. It takes a little bit of sacrifice, some waiting, but I don't believe it's impossible at all. And if you think you can't be wealthy, you could be wrong. And hopefully that's what we'll talk about here. The basic premise of what I'm talking about is the amazing, shocking power of compound interest. The idea that you loan somebody your money and they pay you back more than you loaned them. And people are willing to do that. And if you can get on the saving side of that equation and have people pay you interest never sleeps. Interest works all night while you're sleeping. It works in your favor. And if you're in debt, if you're the one who borrows money, you wake up owing more money than when you went to sleep. Interest never sleeps. We're going to look at the equations, and I'm not going to go into too much detail, but the basic equations of interest, compound interest. Learn to use these equations, and we'll introduce places online. You don't have to be a mathematician to use these. They're fairly simple equations, and there's canned programs online that we'll talk about. And you can go and find out how much things are really going to cost you or how much you can have in the future if you save today. Motivationally, knowing the difference between a need and a want seems like something we need to talk about. We'll get into that. But if you can sacrifice in the near term for a long-term gain, you could have a lot more peace in your life. So I want to get some motivation to plan for your future. Young people have a great advantage because they have time on their side. We also need to put things in perspective, and the idea being enough wealth can make you comfortable. More wealth might just make you too busy with things that don't matter. So, I'm trying to get you to a point where you can be comfortable in your life, but money won't overtake you. We should avoid high risks, And the things I'm talking about may seem a little risky, but they're really not. And I'll go into that. You should always put relationships first. Don't ever put money above your relationships. That's a big mistake. And then finally, be honest and fair. You need to treat people the way you would like to be treated, and that applies to money as well. Sometimes you get a little too ruthless, or oftentimes too ruthless. You need to treat people honestly and fairly, and make sure that they also receive a return for their labors. So I'm going to divide this into, I think, 5 different sections, and this is the first one. I don't want it to be too long. So this is just going over the equations of. I give this lecture. I developed this lecture for students at the high schools that I help teach physics at here where I live. 2 high schools. And I wanted to have them pay attention. And right now, in 2024, the state spends $18,816 per student per year, and that's teachers, administrators, and staff. I don't think that includes the buses and buildings, so it's really more than that. But there's 180 school days per year. 18,816 divided by 180, that's $104 per student per day the taxpayers are willing to spend to put you in school for 13 years. Once you add the buses and lunches, we could send you to Disneyland every day for 13 years, 180 days a year, or we could give you a ski pass even cheaper at a local resort here. So taxpayers are paying a lot. Over 13 years, that's $245,000 your community is willing to spend on you to educate you in a public school system. And so please pay attention. Your school today is already paid for, and all your classmates, their school's paid for. It's up to you to get something out of it, and you should let others do likewise. If you get bored and don't want to listen, don't disrupt other people who do want to listen. I like this Napkin Finance, this guy. You can look this up online. But basically, this kind of boils things down. You might have some money and you can put it in a bank. They'll loan it to somebody over a certain amount of time. You get the money back plus what's called interest. So you get more money back than what you put in, and some amount of money back, and then they pay the bank back, and you make money. That's what's happened. You could do this personally. You could loan money to somebody and they pay you back, but it's more convenient to have an institution involved. Likewise, you can be on the other side of this. You can borrow money. You can borrow $100 over time, but then you have to pay more money back, and that's interest is the cost of using somebody else's money. And you can be on either side of that. You can save money and loan it to other people, or you can not save money, and you might have a good reason for borrowing money, but you better have a really good reason because you're going to have to pay it back. So now we go over here on this side and we talk about compound interest. Interest is when you're not just paying the loan back, the money back, but you're paying a certain percent back. And when you put your money in let's say the stock market, and a fairly stable part of the stock market, not something risky, and it returns over 80 years of the stock market, it's typically returned about 10%, and so we subtract 3% for inflation, and we're going to use the 7% as a standard interest rate. So you put your money in there, and then it accumulates, and every month or every year, every time frame that goes by, it's worth more, and the money that is put in there compounds, which means you get interest on the interest. So the money it's not a linear function. It's not a line. We'll go into that in detail. Now, there's two sides of borrowing. Somebody has to loan the money and somebody has to borrow the money. And if you're on this side of it, you make money because you have a savings account that returns money. You buy, there's all kinds of things you can invest in. CDs are relatively safe anyway, or you can loan the money to another person and they pay you more money back. On the other side of that, if you have to borrow money, especially if you do it unwisely, you pay a lot more than you think you're paying, and generally that's if you run a credit card balance and you have to pay interest. They charge a lot of interest. Auto loans, unpaid bills. If you're late paying the bill, then you have to pay extra, and you have to pay interest on that extra. And student loans, and I'll go into student loans in another section. And sometimes they can be okay, but a lot of times they can just be terrible for you. And we're in a current atmosphere where a lot of people are getting student loans to go to college, and it just doesn't pan out for them. And so we'll talk about that. So here's the basic equations. There's two of them we're going to talk about. And FV means future value. So basically, how much is money worth in the future? Money's worth more today than it is in the future. That's the time value of money. If you save $1,000 today, it's worth a lot more than $1,000 10 years from now. Okay, this is the equation if you have just a single amount, and I'll go into this more in detail. This is the equation if you're making monthly or yearly payments into something. And these equations, there's I, that's the interest rate, and N is the number of periods, and we'll go into this. So don't be afraid of the math. It's just something you can do on a calculator, adding, multiplying, and then this exponent here for the time involved. So don't be afraid of these equations. These are friendly equations, and you don't even have to do the math because I'm going to show you online calculators that let you do this. So, time value of money. Basically, let's say I'm saving $1,000, okay? And I get an annual interest rate of 10% to make it easy to calculate. So after 1 year, I go $1,000 times 10%. That's $100 plus my original $1,000. And now I have $1,100 just after 1 year. This is $1,000 that I earned and put in there. And this is $100 that someone, an institution, paid me back because I loaned them this money for 1 year. And so as we can make this table and go down, but there's calculations. These equations make this table really easy. You don't have to calculate this out, but we'll do it. We'll look at this. So the second year, I have my $1,100. And that makes 10% interest. So that's $110 plus my original $1,100. And I get $1,210. Now, what's interesting is if it was just simple interest, then this would be a $1,200. I would get 10% every year. But there's an extra $10 in here, and that's the compound interest. Okay, and it doesn't look like much in the front end, but as time goes on, that starts to be really powerful. You start out, and the higher the interest rate, the more powerful that is, because this is not a straight line. This is a curved line. It can go up a lot with a lot of years, but you have to be patient and start early. So in my fourth year, anyway, this continues on. You can see instead of $1,100, $1,200, $1,300, $1,400, there's extra money in here, and that's the compound interest adding in. What you see from this table is my $1,000 after 8 years has turned into over $2,000. It's doubled in 8 years. And what you see is as time goes on, that's gone. This is twice as much. This is 3 times as much, and it only took 4 extra years to do it. This is 4 times as much. And so the amount of time to to make your money grow gets shorter. And finally, at the bottom here, after 20 years, I have my $1,000 has turned into $6,727 just by the power. I didn't put anything extra in. I just saved $1,000, and I just waited 20 years to do it. So if you're 18 now, when you're 38 years old, you've got $6,727. Okay? So you can do it by this table, or you can do it with a calculator. We have equations to make this easy to do. Future value, how much it's worth in the future, equals the present value, my $1,000, times 1 plus the interest rate to the n power, to how long I save that. So future value, in our case, $1,000 times 1 plus 0.1. Our interest rate is 10%. 10% you can also write as 0.10. Okay? And then to the 20th power. And this is a function on your calculator. And you get familiar with how to do this pretty easy. So we run these calculations. $1,000 times 1.1 to the 20th power. $1,000 times 6.727, that's 1.1 to the 20th power. And it's a simple multiplier. We get the same exact answer, $6,727. So our math has made this whole table just a lot easier to use. Okay, and that's what math is a way to make your life easy. You don't have to make this giant table. You can just use this equation. Okay. So we'll go over it again. If I save a certain amount one time, I put $1,000, I save it one time. How much is it worth in the future? And this is the equation again. FV is future value. PV is present value, the amount I start with. I is the interest rate, 7%. Usually when you say 7% or 6 or 9%, that means per year, the annual or APR percentage rate. Okay, and 7% is 7 divided by 100, and you can write it as 0.07 each year annually. Now, monthly, you would divide by 12. That's the monthly interest rate. So 0.07 divided by 12 is this number. That's how much a month the interest is. Okay, now in these equations, what you really have to do is, if you're using a monthly interest rate, then you need monthly time periods. Okay, and if you leave it in years, you need to use years down here. And so you're either multiplying by 12 or dividing by 12. Multiplying the number of time periods by 12 to get months from years, or you just have to be consistent with the time period when you're using the interest rate. And we'll go into that in more detail. You can calculate the interest. It can be compounded annually, monthly, or daily, or anything you want. The more often it's compounded, it'll be a little more money. But so here we are. We have our equation, and this is just a little different way of writing it. Present value $1,000, interest rate 7%, number of years 30 years this time. Okay. It's a lower interest rate than on the previous page, but it's for a longer period of time. So if I save $1,000 just one time, I get $1,000 and I put it in an investment in the stock market. And like I said, over the 80 years of the stock market, the average is around 10% a year, but I subtract 3% to account for inflation. So 7% is a pretty reasonable number. Yeah, the stock market goes up and it goes down, but over time, over a long period of time, it goes up by 7% a year. And we'll just keep it simple. That's what we'll use. So we do 1,000 times 1 plus 0.07 to the 30th power. We just compounding this yearly. We don't change it to months. And that's a multiplier of 7.61. So after 30 years, my $1,000 has turned into $7,612. Now, this is calculator.net. And I want you to get you familiar with calculator.net, because it's a place you can go on the internet where you don't have to even know how to use a calculator. You can say my initial investment is $1,000. I don't make any monthly or annual contributions. My interest rate 7%, compounded annually, and then I'm going to save it for 30 years. And it makes this nice table for you. Okay, after 30 years, we get the same exact number we calculated before. And then here's a summary of it. I saved $1,000 for 30 years. The interest is much more than what I initially saved. So here we are. This gives you a nice little graph. My initial investment was $1,000, and I keep that for 30 years. But the interest compounds. It goes up on this curve, and I end up with $7,600 instead of $1,000. And that really is the power of compound interest. And that's what I want to use to motivate you to say, yeah, if I save early, there's no reason why I can't come out pretty good financially. Now, there's a second equation, and that instead of starting with an initial value, you are going to pay so much a month, a smaller amount every month or every year. And how much is it going to be worth after a certain amount of time? And this is the equation that tells you that. Future value equals the payment per the period. This is 1 plus the interest rate to the nth power. That's the number of time periods. Minus 1 divided by all that divided by the interest rate. Now, if you're comfortable with your calculating on your calculator, you can do this. But again, I have an online calculator that can do this for you. And remember, 7% is 7 divided by 100. So if you're going to use this, just keep your interest rate and your time in the same time period units, if it's months or years or whatever it is. So future value equals payment. That's the equation. If I save $200 a month, and I'm just going to calculate the interest annually to keep it simple. So I can save $2,400 per year. $200 a month for most people. Some people think, oh, that's out of my, I couldn't possibly save $200 a month. But you can. People spend $200 a month once you're working. In our state, our minimum wage is $16.28 an hour, I think. So that's, I think, $32,000 a year. And if you ought to really think about, I'm trying to motivate you to say, yeah, I can save $200 a month because this is what it gets me after 30 years. I get comfortable. Okay, so if we make a payment of $2,400 per year, that's what we save, and we're saving it in the stock market at 7%. Okay, in 30 years, this is a calculation. We plug these numbers in, and we get $226,000 in 30 years. And this is the amazing thing is, I was just saving $200 a month, and I did it for a long time. And it was a bit of a pain, but after a while, my income went up and the $200 a month got easier to pay. And look how much it turned into. So if you're 20 years old, by the time you're 50 years old, all of a sudden you got this giant chunk of money. And let's check it with calculator.net. Say, I don't even have to do the calculations. I got this calculator.net. Now, there are a whole bunch of financial calculators here, and you can, we're only going to use a few of them. And this is the investment calculator. If I start with no money at all, but for 30 years, I save $200 a month, $2,400 annually. You calculate that, and it gives you this nice schedule. You notice about this. I'm saving $2,400 a month. $2,400. So this should be $4,800, but that extra $168, that's the compound interest. That number just keeps getting bigger until, look at this. After only 12 years, I'm still putting $200 a month in, $2,400 a year, but the interest is greater than what I'm putting in. And interest, I didn't have to work for it. I had to wait for it. The interest is accumulating. So here's a nice little graph. I accumulate this, and if I'd put this under my pillow, I'd only end up with $72,000. That's how much I put in. But the interest is getting me $154,000 for a total of $227,000. And that's what I want to convey, is the power of interest. So we checked that. There's only a couple charts left here on this first session. Time value of money. Money now is worth more than money is in the future. Okay? If you start saving in your 20s, you're way ahead than if you wait. And yeah, it's harder to save when you're in your 20s, but you're going to, you start earning money, and if you can save some of it, you're just way ahead. Okay, this is if a person started at 25, and this is that compound interest curve. Okay, and if that same person waited 10 years and started saving the same amount when they were 35, this is how much they'd end up with. And the point here is that if a person waited until they were 40 to start saving, and they saved twice as much money every month than the person who started at 25, they would never catch up. So starting early is way beneficial to you. If you're young, time is on your side. You can start saving and just pretend it's not your money. It's in an investment account, and you just wait. And anyone can do this. It's not just for rich people. This is my last chart for today. The power of compounding. And this is from this website, Listen Money Matters. So we got investor number one. This girl, she starts at age 25, and she sets aside $5,000 a year for 10 years. Okay? She makes, even if she makes minimum wage, $32,000 a year, she can save $5,000 of that. Okay, and yeah, she might have to make some sacrifices to do that, and she might have to say, well, I'm going to go on a trip later in life. I'm going to buy this. I'm not going to buy as nice a car, whatever. We'll get into all those things about deciding how much you can afford later on. And so, investor one, this girl, she starts saving at age 25. She sets aside $5,000 a year, and she saves it for 10 years, and then she doesn't do anything after that. She saves $5,000 a year for 10 years and nothing after that. Okay? So after this, she doesn't make any more contributions. She just lets it ride in the investment, and she ends up, when she's 65, she has $787,000 in her account. This guy, investor number two, he started late. He started at age 35. You can start late, yeah. This is interesting because a lot of people I talk this stuff over with are older, and they say, gee, I wish I'd have known this when I was young. It doesn't do me any good to know this when I'm 60. So I'm basically trying to talk to young people. Investor number two here, he starts at age 35, and he saves the same amount, $5,000 per year, and he does it not just for 10 years like she did. He does it for 30 years. And he's doing really good. He did save $612,000. That's what that account turned into. But if he'd have started 10 years earlier, he wouldn't have to do that. So that's what I'm saying. The time value of money. Money saved now and invested now is worth a lot more than money saved and invested later. This $5,000 a year is $416 a month. Now, is that a reasonable amount? For some people, no. For most people, I think it is a reasonable amount. So the idea that I can start when I'm 25 or 35, and I can end up with money that I can retire comfortably and live a really nice life and do whatever I wanted to do when I retire. And you got to balance that with doing things that you like to do right now. But you ought to have some balance there. So that's basically what I wanted to talk about in this first session. The next session will go real life examples to motivate you to understand that you can save and you too can know what wealthy people know. So I hope you enjoyed that, and I'll try to be a little shorter next time. Thanks. Bye.